Hello all, I am Eugene and this is our class for Sierra Girls Code Club week 3 and we will be dealing with Python. So in our class for week 3 we should cover something that has to deal with image classification. Yeah, and for week 4 we should cover natural language processing, but we won't be able to do these without some knowledge in Python. Yeah, and so I have to introduce you to Python, at least with the basics, and some of the knowledge you'll have to go online and search for yourselves, expand on what we will do here. So we'll start. We are working with Kaggle, and let me start by resetting the environment. In Kaggle, we normally come here with the 3 dots, more settings, click on it to say that we want to restart and clear cells. Okay, so this will reset everything because it's a project that I worked on, so that I'll be able to some extent with you guys. So we are going to cover all of these. So let's start. So in Kaggle we have things that we call cells. These are these cells. They enable us to run our codes, and we have things that we call markup, where we can write guiding information like these ones that help us understand what we are going to do in our code. It's not mandatory for you to do this one, the markup, the markdown. Sorry, the markdown is not mandatory, but when you want to write a code, you come here and click on code. If you want to do a markdown, you come here and click on markdown. For instance, if I want to write code, if I click on this one, it will open a new cell for me. I can remove this cell too, like this. If I want to do a markdown, it's different. It comes like this, and you will see something like BI, which enables you to format your text. Yeah, you want to make it bold, you want to make it an italic, and the likes. And you move it. So let's start. One of the things that you do in Python is to print words, yeah, to give you output, or to print something, an object. So in this case, we are going to print hello world. To print hello world or to print something in Python, we type a function. Functions are usually words, they are keywords, for instance, print, and they have a braces like this one, like a parenthesis. Okay, so I type my function print here and hello world. So when you want to run yourself, you can click on this button, execute. And when you do it, you see it's trying to execute. I'm working with this over the internet, so it could be a little bit slow. When you want to do something on this environment, you need to come to kaggle.com and start. Okay, so now it's run. So when you want to run your first cell, it usually takes some time to display this word hello world, but the rest won't take time. So if I want to say hello Eugene, I will just come here and type hello Eugene and press one button. See, it loads faster now. Okay. In Python, or in most programming languages, or all programming languages, sorry, we have what we call variables. Variables are like containers used to store data. Okay. So in Python, variables should always start with small letters, and variables should not be keyword. For instance, we can't use this word print as a variable. Yeah. There are keywords in Python which we can't use as a variable, like print and some of these words. But you can use names of things like animals, persons, computers, schools, and so forth. Yeah. These are examples of variables here. We have here product name. So we said variables are like containers here. In this case, product name is a container. What is it storing? It's storing the name of this computer, HP computer. Okay, so what if we want to print that one? Let me just cut these guys out and try to print it. You see. So you see, instead of just printing the name Eugene, I've put Eugene in a variable, and now I can just say print product name. So if you can see, I don't need to put braces to print Eugene anymore. I'm printing the container, but the container has something in it, and it has the name of the type of computer here, which is HP, or the product name, HP computer. So why do we do this? We put things into variables because things do change. For instance, if I want to print Lenovo computer, I don't need to change anything in the print function anymore. I just need to change the data. Yeah, Lenovo. I just need to change the data and run it. You see that it prints the product name still, even if it changes. Okay, so let's put the other guys back. Now we did product count. The product count stands for number of products, number of products we have in our store, for instance. Let's assume we have a store. Okay, so we can print product count. This number can also change. But if you observe, here we have something like this that quotes the word. But when it comes to the number, we didn't put it. I will explain why. Okay, we have product cost, which has 10,000.00. If you look at this also, let's make it 10,000.05. Okay, for better knowledge, you can see that it's different from this one. This one does not have any decimal point, but when we come here, we have this a decimal point. Yeah, and we also have this one, which we say is available false. Okay, let me type it so we can print it. Print is available. Okay, so let's run this code and see if we can get all of them. So we see here that okay, product name, when we print, what do we get? We get Lenovo computer. Product count, when we print it, what do we get? 85. Product cost, when we print it, what do we get? 10,000.05, and it's available. When we print it, we get false. If we put 2 here, we are sure to get 2. Okay, so these are our variables. What we should learn from this part is that these ones, product name, product count, product cost, and it's available. They are variables because they store data. Okay, so now because they store data, let's look at what is the data and what are the types of data that we do have. Okay, so what are data? What are data? For instance, data is anything, yeah, that has value. Okay, it's a data, and yeah, let me see. Okay, so data is anything that has value. Okay, and they could be integers. So integers are numbers that have, for instance, minus or plus in front of them. You know that for a number to have plus in front of it, you don't need to have to get the plus there. So an integer number is a number that could either be negative or positive. Negative numbers have minus in front of them. Positive numbers do not have anything in front of them, but they are positive. Yeah. So we have minus 100, which is a negative number. We have 0, which is usually an intermediary between the positive and negative numbers, and we have the positives, which are, for instance, 6, 8. Okay, so these are what we call integers. They are whole numbers that are either negative. They are that can be either be negative or positive. So what are floats? Floats are numbers. Floats are also numbers there, but they are decimal points. They are numbers with short decimal points like 1.01, 1.2. It can even be, I think, -1. It can also have positive and negatives, but they do have, decimal points behind them. Okay, these ones do not have decimal points, integers. We have double. Double are inte- Doubles are also uh, numbers with decimal points like this one, but they have long decimal points like pi. Okay, so we go again and say data. We have other ones that we refer to as strings. Okay, so what are strings? So strings are alphanumerical or letters. Okay, strings are usually letters. They can also be numbers, letters and numbers. But the difference between the numbers that are strings are that they are enclosed with something like they are enclosed with something like this. For instance, if I write my number 2 and I put it in this kind of thing, yeah, in this quotation marks, then it is a string. So the quotation mark can either be double or single, like this one. 4 is a string. If I write my name, Eugene, this is a string. Okay, but I can't write my name like this, Eugene. I can write a number like that because, and Python will see it as a number, but if I write a letter like this, it will give me an error. But if I write a number in string, it will take it as a string. So what is the difference? Any number that is in a string cannot be used for calculation. So if a number is encased in quotation mark, for instance, it cannot be used in any form of calculation. But if we use it as a number that is either integers, floats, or double, then we can use it for calculations. Okay, so we can move. So data are often oh, sorry for this typo. So we say data are often recognized as objects that are valuable. There are data types ranging from string, which are text, and they are often surrounded by quotation marks. You see these ones or these ones, like we did above. We have numbers. So numbers, for instance, these are items such as integers and decimals, like the ones above here. They are numbers. Okay. We have Boolean. These often represents a true or false situation, like we did above here. So something can either be true or false. Okay. So any situation that we have to represent by true or false is what we refer to as a Boolean. So you can research some of these for yourselves and see what you could come up with. So now, if we want to show the type of data, we are doing another function called type. We did the first function called print, which allows us to print or show what is stored in a variable or what is shown in the data. Yeah? So now let's see what if we want to see the type of data. Now, for instance, we did something above here, which we call product name. Yeah? For instance, product name. How do we know that product name is a string or a number of sorts? We use the type. So put the variable inside the type function and we run it. Let's see. So whenever I see str, it's short for string. Okay. What about product cost? Remember, product cost has 85, right? Does not have a decimal point. Let's see what type of data it is. Float. Okay. So product cost. Why is product cost a float? Okay, so this is the product cost here. This one, 1000.05. It has a short decimal point, so it's called a float. Okay. So what if we want to do for the product count? This one. Let's run it. It's called an int. So if you look at it up here, 85, you see that 85 is an integer. Sorry, I previously I made a mistake between the product count and product cost. So the product cost is a float, product count is an integer, as we can see here in our types. Yeah, product cost float, product type integer. Product name is a string. Now we come to data type conversion. Okay, what if we want to convert from number to string and all that? So okay, before we do that, let's think before we do this data conversion, because we are going to treat it, I think, let me see. We are going to treat it somewhere around here. But I will do it with you guys. Okay, so we do it here. But let me just brief you guys about it here. So for data conversion, let's say you want to convert a string to an integer, yeah? Or let's say you want to convert an integer to a string. Let's say that. Okay, let me do it here. Let me say integer to string conversion. Let's see how we go about it. Okay, I need to space this, guys, for you to see it bold. Integer to string, yeah. So let's say we declare a variable that is called what do we call it now? Let's say we call it number. Okay, let me call it age. Ages. Yeah. And let me just name it, for instance, 5. So in this case, 5 is a number. How do we know? Let's see. 5 is an integer. If we do type and say ages and we run the code, we see that we get int here. But we want to convert ages to a string, because maybe we want to use it in a sentence like this. And when we want to do sentences, all of them should be strings. Okay. And what do we do? So now let's see ages. We go again and say ages is equals to str bracket ages. Okay. So now we declare a new variable called ages again. You could name this one anyone. For instance, I call it ages1 equals to str ages, which is this one here. Now let's see type. What type we get for ages1? You see that ages1 is now a string. Okay. Still, the type, for instance, ages is going to still be ages. If we want to see the data type for ages is still an integer. But if we convert, once you get what is data type for this one now, for this variable, which is ages1, we see that ages1 is now a string because we converted using this one, str ages. So this converts ages to a string. And if we want to convert ages1 again to an integer or to a float, yes, what do we do? Let's try something. Want to convert ages1 to a float. What do? We say ages2 is equals to float ages1. Let's see if it will work. I don't know. Okay, so now let's see the data type. Type ages2. So now we see that ages2 is a float. Let's print it to see what it will look like. For a float, it's supposed to have a decimal point here. So you see, it gives us 5.0 instead of 5, which used to be an integer. So these are how we. So now let's print all of them. Let's see something. So let's print ages. Yeah, which we know that ages is an integer. Let me say int. Let's also print ages 1, which we know that is a string str. So this one I'm doing here, the one that has this pound symbol, is a comment. Okay, so I'm just trying to guide you. This one should be a float. So if we go through it, see that we have ages 1, ages, a string, sorry, an integer. This one is a string, and this one is a float. Okay, so now we've seen how the conversion works. Let's just keep into this one to see. We want to say that our product name is product name. So remember we did something up here that shows the product name, product count, product cost is available here. So our product name, for instance, is Lenovo. Lenovo is already a string. Why? Because it has this double quotation, right? These ones are all numbers and boolean. So let's see how we use them in here. Product name is product name. We don't do any conversion here because it's already a string. Look at this one, it's a string. So we want to print this here. Product name is product name. We have what we call concatenations. They are used to join parts of your code, like a variable to a data or two or more variables. Okay. So in this case, product name is, for instance, a string here, a data string. We want to join it to product name here, but see, I spaced it. Or else when you join, they will be fixed together. So I space product name is space product name plus its cost. Let me put here and see, I also space this and its cost millions plus product costs. So let's run this one. Let's see what it does. See, it says product name is Lenovo computer and it costs millions 1,000.05 and I only have 85 left in my store. See, if you want, you can put this in a variable. This entire thing that we typed here, you can put it in a variable. I call it variable narration. You can call it anything. So let's say we want to print narration, which is this one above here. All you need to do is print, see that you get this data. Okay. We also have, so like I said earlier, you can do calculations with your variables, but they need to be numbers, either decimals, either floats, or integers, or double. So in this case, we have Dell count, which is 10, Lenovo count, which is 13. We want to get the total count of laptops. So we say Dell count plus Lenovo count, and we say we print. There are, remember, when we want to use them in a string, for instance, in a sentence that has to do with a string, we use the string conversion, meaning we need to convert these integers, because these are integers, mind you. We need to convert them to strings, yeah? So we do this conversion. And we could come here and now say, run it, see that there are 23 laptops in my store. If you add this number, for instance, 16, and run it, there are 29 laptops in my store. So we can use variables to work like this. You can also use them to do multiplication and division, subtraction, anything you want, as long as they are integers, floats, or doubles. So now, we also use Python to the interaction. For instance, here, we call it my name. We want to use it to input, for you to input, okay? So here, when I press run, see what happens. So the input is a function. So we've done print, which is a function here. We've done type, which shows you the type of data, and input, which allows you to make an input to your application, like to type something. So it asks you, what is your name? So I have to respond. My name is Eugene Jones, and see what happens next. Okay. When I press this, I press Control plus Enter. See what it does. What is your name? Eugene Jones. So here, I store the variable as my name here. I could use this my name anywhere I want. So print hello my name, which is hello Eugene Jones. But if you see here, I spaced it. If you don't space it, see what happens. It will join them. So that's why I use spacings here. It's a technique. So hello my name. My name is a variable that holds what data? Eugene Jones, which is collected using this function. Now it wants to know my date of birth. I'm not going to show you my date of birth. I'm going to put a fake one. So let's run it. Okay, my date of birth is 1901 or 1904. And okay, if I press Control on my keyboard, I press Control, I hold it, and I press Enter. Okay. So now it wants to calculate my age. So my age is equal to the current year, which is 2024, minus my birth year. So if you see here, I'm converting this to an integer y. Anytime you enter something here, it takes it as a string. So if you want to use that thing for calculation, you have to use integer, or if it's a float, you have to use float. So I'm converting from a string, which is normally captured here. Even if it's a number, it's always takes as a string. So I have to convert int birth year. Remember, this is my birth year, right? If I print, okay. So now what happens is, let me remove this, let you see something, because it's going to be confusing. If I say print age, okay, print age, see what happens. It shows that my age is 120. Wow, I'm old. And now, what if I want to use it in a sentence? If I want to use it in a sentence, I have to convert this age again to a string, which I did here. So it says your age is string str age. Okay, so if I run this code, you see that it says your age is 120. So we can do calculations, lots of calculations using this technique, where you can input numbers. For instance, here we are asked to enter the value of x, and also enter the value of y. So let's try it. When we run it, it will ask us to enter the value of x. Let me enter 23. Press Control and enter. And value of y, let me say 25. Control and enter. Okay, now I've done this. Now I have to convert them to integer first. X is equals to int x, y is equals to int y, and I want to do some calculations like z is equals to 2 times x plus 3 times y. Let's see what this gives us, which should be z is equals to 2 times what? 23 bracket plus 3 times 25. So let me do it with my head first and see. 2 times 23 is supposed to be 46, and 3 times 25 is supposed to be 75. So 75 plus what did we get here? We got 2 times 23 is supposed to be 46, right? So 75 plus, or 46 plus 75 is supposed to give us 46 plus 75 is supposed to give us 141. Maybe. Let's see if I'm right. Wrong. Why? Wait, but here, okay, I made a mistake. It should be 3 plus y. It should be 2 times 23, which is 46, plus 3 plus y. Okay, let's move this as 3 times y and see. Okay, 121. I made a mistake. Yeah. So here we had plus. This is why we got 74. So you can try it, yeah? You can try it with different numbers and see what happens. So we also have what we call logical operators. Logical operators are signs that help us to compare things in our code or our code here, our variables in our data. So we have the greater than symbol. We have greater than or equals to. We have less than or equals to. We have um, what we usually use to call the is or the same as. We have what we used to call is not or not equals to, not equals to. This symbol this symbol usually stands for not in programming. Yeah, we have and. Maybe you want to compare that this and this are equal or this and this are true. We have the or, yeah, and we have the not. Okay, so let's see something. So here we say we got something like price is equals to 100. So now print price is greater than 120. Let's see what happens. So now we have to check, is 100 greater than 120? False. So this is where we get Boolean. Boolean usually works with these symbols, okay? Here we see that price is not greater than 120. So it gives us false, that this statement is false. Now we say price is less than 120. Yes, that is true. Because price is 100 and 120 is greater than 100. We have price equals to 25 here in this one. But to say print price is greater than 10 and price is less than 25. Is it true? Than 30, sorry. So in here, 25 is greater than 10, right? And 25 is less than 30. Yes, it's true. So we move and see. Here we say price is equals to the same 25 here, but price, if you want, we don't need to declare price here anymore. But maybe you want to change yours later, so let me leave it like that. So price is greater than 25 and price, I think it's the same as, okay, in here we say price is greater than 25. Mind you, the price is 25 here. Price is greater than 25 and price is less than 30. This is false because price is not greater than 25. Okay, this one is true, but we use the and. Anytime we use the and, if one is right and one side is wrong, it will give you false. It only gives you true if both sides are right. If we use or here, then it's going to give us true because one of the logic, one part is correct, the other part is wrong, so we use or. Here we say price is equal to 25 here. Price is greater than 25 or price is less than 30. So this is going to give us true because this part of the code is correct, this part of the code is wrong. Because we use or to give us true. We have the next one, which is price is equals to 25 here, and say price is not. You put the not in front of here. Price is not greater than 30. Okay. So here we are saying 25 is not greater than 30, which is, let me see. Okay. No, sorry. Here we are saying that price is not less than 30. Meaning 25 is not less than 30, which is false because 25 is actually less than 30. If we have this symbol, like I said earlier, 25 is not greater than 30, then it should be 2. Because 25 is really not greater than 30. Now we come to if statement. Okay. So for all of these that I'm doing, we have a WhatsApp group that you all know about. You can always come to the WhatsApp group. You can ask. and see what I will be able to answer your questions. Joy will also be able to answer your questions. Okay. So let's go with if statement. So we are going to use temperatures as our examples. So if statements, they are used to show logics that if this happens, for instance, if a certain condition happens, then let this be. Yeah. Else, if it does not happen, let another thing be. So let's see how it works. So here we say we're asking you now to enter a temperature. So in this case, we have another technique that we can say when we do the input, we can make it a float or an integer, so you don't have to do any conversion later again. For instance, when you input, if we only use the input, then when we are done, we need to convert this temperature into a float later. But we don't need. But if you with Python, you can always use this one and encase the input function in it. Okay, so it's asking you what is the temperature in your room, and we run it, and we see that the temperature in my room is 120 degrees. Okay, control enter. Okay, so 120 here. So in here, I'm going to see if temperature is greater than 30, let's the code print, it's a hot day. Else if in Python, we want to say else if we do like this, else if temperature is greater than 20, print it seems like a cold day, like a nice day, sorry. Else if temperature is greater than 10, print it's a cold day. Else print it's obviously cold. So let's see what is going to print for me. My room. It's a hot day, and indeed it's a hot day here. So this is how the if else code works. Yeah. So you can explore more of this one and see how far you can go with it. Any questions? Any question you could ask me or Joy in the group. And we'll go to list. Okay, so in Python we have what we call list. A list is a set of items which could be made up of different data types. For example, numeric, which are numbers, like the floats, integers, and the decimal, the double, which are decimals, and alphanumeric, which can be numbers, letters, that okay, which are sorry letters, A, B, C, D to Z. Okay, so in here, we have an example of list. Okay, we have this list that I call animals. If you observe in here, we have more than one data in a variable. So a list is a collection of items or a set of items. So these are collections of animals. We have cats, dogs, birds, mice, chickens. These are all animals, right? So let's print them and see. So you see, when we print them, we get them like this. We we identify objects in the list using numbers. Okay. So normally, even though we see the list like this, we see the data like this, but we represent this data using numbers beginning with zeros. So the first item that you see, yeah, it should be zero. This one is this the second item is one. So in the list, for instance, we start counting like these items 0, 1, 2, 3, 4, and so on. We increment, but we start counting like 0, 1, 2, 3 upwards. Okay. Next, so let's see. We want to get the zeroth item in our code. Let's see, cats. See, if we put one, if the one part of it, dogs, which in the way that we count, we normally say is the second, but this is the zeroth item. This is the first, and this is the second. This is the second, and run it and see. But so this is the way that we see the part that it's the container, yeah. So now we have what we call slicing. Yeah. So we say below, we identified all animals in the list that are greater than or equals to 0, which is here, but less than 4. This is called slicing. So let's see what happens. In our list, we started slicing from 0, which is the first one cat, up to mice, which is the 0, 1, 2, 3. Because we don't normally print the 4 when we slice like this. Okay. If we want to slice to 3, 0 to 3, then we find out that mice is not going to be in here. Let's see. Okay. So this is what we do. And next, okay, let me slice again from, let's start from 1, which is going to only be this and this. Let's see. So dogs and birds. Okay. We say below, we added or appended a new animal to the existing list. For instance, let's do it multiple times and see. So in here, what if we want to add another animal to this list? Like, for instance, we want to add eagle. What we do is that we use the word animals, which is the variable that stores the animals up here. If you look at it, animals, and we say dot append. Okay, let me type it for you to see. So we say animals dot append. So you see, in Python, when you start typing, you see that it's a function. You press tab and to complete it, then we enter. What do we want to append? We want to append the animal eagle. Okay. So when we append it, we can print and see what happens. So you see, eagle is there. So what if we appended it for the second time? Eagle. So now we see 2 eagles. Okay. We could also append a number here, like this one, 9.2. So we can say that, okay, but 9.2 is not an animal. And why do we put it there? And also, you can observe that 9.2 is a float and not a string. Well, the beauty of a list is that a list can contain different data types. You can store a float, you can store a string, you can store an integer, as you may like. Okay. And what if we want to remove, for instance, something like we added eagle twice? We want to remove eagle. When we do this, it will remove one of the eagle, the first one. If we, let's see. So that we see that we have removed the first eagle here. If we want to remove the 9.2 also, we just need to type it here. Remember, it's not a string, so we have to type like this, 9.2. Remove 9.2 from our list. And on. So we see that we only have these ones now, but 9.2 has been removed. Okay. Now we have what we call arrays. Arrays work the same way as lists. The only difference between arrays and lists are that one, array only contains the same type of data. For instance, if you are storing a string in an array, all the data must be string. If you are storing an integer, all must be integer. If you are storing float, all must be float. If you want to mix them, like integers and floats, then you can store them in a list. Okay, so an array is very strict about this. So when we want to use an array in Python, we first of all import it in our code at the top. We use the keyword import array. Okay, then we start out arrays below. So we start our array below by showing the data type we want in our array. Sorry for this typo, I'll be correcting them as we go along. So we start our array below by showing the data type we want in our array. Example, I for integer, F for float, Y for unique, U for Unicode, sorry, U for Unicode, and the sorts. So we're having a thunder here. So a thunderstorm. So now let's say we want to store this data in the array. Let's call them numbers. How do we do it? We say numbers is equals to array, which is this one, array point array. So we specify the data type. This data type is for integers, mind you. Then we say comma, and we store an array in this bracket 1, 2, 3, 4. Okay, we press run. Wow, I got an error. So we say array is not defined. Why? Because I did not run this first. Okay, I need to run it first. Then I come here, I press this. We see that our array is now stored like this 1, 2, 3, 4. So we can also manipulate our arrays just like we do in our list. So for you to manipulate your array, just watch what we did for our list, and you can also do this for the array. If you want to know, for instance, array, the third item in the array, you can simply say numbers 3, and it will show that the third item is 4. If you want to know the 0th item, you can see that what is it? 1. Okay, so if we want to make them float like this one, if we want our arrays to be float, we just have to put F there, and voila, we can see that we have them 1 point like this. If we now run this one, we see that it is 1.0, not 2. So a float put decimal points in behind. So even if you don't put any decimal points here, it can sense that okay, this is 1.0, this is 1.2, this is 1.3. So that's how it works. And we'll continue with a dictionary. So what is a dictionary? A dictionary in Python is a collection of key value pairs. Yeah. Each key is unique, and it is used to access the corresponding value. So in here, for instance, this is a key name, and this is the value that it stores. So what does a dictionary do? It stores variable and the data, but it can store multiple variables and data. For instance, name Eugene, age is a variable, right? 85. City, I forgot, my age is now 120 officially. City, Freetown. Okay. So this is what basically a dictionary is. It's able to store multiple variables and their data. So if we run it, we'll get something like this: name Eugene, age 120, city Freetown, and you see that they are in the curly braces. So what if we want to do multiple data sets in a dictionary like this? We put them, for instance, people. I can call them people, and we put them in this symbol, in this bracket, and we still use our curly braces like this, like we did here, and we just come and say name, Eugene, Joy, Margaret, and the rest. So if I run this one now, so that it prints the people like this. Okay, this is normally what we call JSON format. Okay, you can check that up. So now I think we're going to end our introduction to Python in loops. So for loops are used to go over, to iterate, to go over a data set. Yeah, we have different kinds of loop, such as while loop and for loop in Python, but we will focus on for loops. Okay, so you can check the other one, while loop. So for loop, we want to loop through the array of numbers above. Okay, so remember we have our numbers here, where we did an array of numbers here. These ones, 1.0, 1.2, 1.3, 1.4. Okay, so let me just copy them so that you won't forget them, and bring them here as comments. I will comment them. So here, say we want to look through our arrays of numbers, array of numbers above brackets. Let me put them here so that you see these ones. How do we go about it? So we say for num, here you can put for num anything you want, but we are saying that for num in numbers. Yeah, that means for each num, for each item in number. Okay, let me use item here to make it easy. So for each item in numbers, print the item one by one. So it's for you to go through all of them and print them one by one. That is what loop is all about. To the last, from the first to the last, it goes through them. So it prints 1.0. I forgot that I converted these ones to. So it prints something like this: 1.0, 2.0, 3.0, and 4.0. So you see, it prints them one for each item in this array, print them one by one. So we also want to look through the list of animals. Remember the animals, yeah? So we want to look through them one by one. For each animal, look for each animal in animals, print the animal one by one. Print the animals one by one. So it prints this. Let's see. Cats, dogs, birds, and the rest. Eagle. Okay. We can look through a dictionary, the one we created above. So to look through a dictionary, it's quite different. You have to do it one of these methods here. For instance, for key, comma value in for instance, my dictionary, it up here, if you look at it, I named this one, the first one, DICT. Yeah. So my dictionary dot items print the key, which is this one, and value. So this one is simple, but it looks a little bit complex. So it's like name, age, and city for you like this. So another method that we could use, for instance, we could say for item in my dictionary, DICT, yeah, print. In Python, we have what we call indentation. This is very important. When you press enter, after like some list 4, you have to press tab key to go to this next line, or else your code won't work. That is called indentation. You have to give some space in the next line when you are doing a function like this one. When you do this, whenever your code has this, for instance, look at it. You see, it will come for itself. Okay. If I do this, I press enter, it will come to this place by default. Okay. So that is what we call indentation, and Python takes it very personal. It likes it. So now I'm doing this one using this method. Let's see what happens. So now in here, when I said for each item in my dictionary, print item, it only prints the key, but not the value. Okay. Let me say my dictionary dot items. Let's see what it does. So when I do it like this now, it prints what? The name and the key and the value. Key and value, key and value. So it's the same thing that was done up here. The only difference was in here we don't have these comma, these if we don't have these long things here. We made it simple. Okay. So you can choose what to use. Let's experiment. I haven't done this before, but let's see. If I enclose this one like this, if I enclose it like this, I think it's going to give me an error. Okay. So when I do like this, it still gives me this kind of thing, which means it's not necessary. Okay, print items. So we can make our work simple like this, or we can make, but if you look at it, it's a bit different from what we have here. Okay, next, we want to print for person in people, like the ones that we have up here. We have people here, right? We want to print all of them. So we did something like this. For person, that means print for each people. We want to show them person by person their data. Okay, so you see we have all of them. Another way to print it is like this. For person in people, print f name. So you can go through them. Let me press and see what happens. So you see that they are a little bit different. Okay, so they are like this, and These ones have the curly braces, the JSON format. Well, almost JSON format, and these ones are showing the data. They show the same data, by the way. Okay, so we can even look through a string, which is where we'll end the basics. For instance, if I want to look through my name and show, I just want to show you what a loop is all about. For instance, if you have this data, this entire thing, name, looping means it will take them one by one by one. So here I'm saying for each character, which is char, yeah, you could name this one anything for each item in my name. I could say my name is the name of the variable. So for each item in my name, print item, print item. So for each item in my name, print item, and it will print my name one by one. UEUGENE. So this is where we end our basics, our introduction to Python. I will do another video that will show how we analyze data, how we do image classification, and we'll cover that to end week 3, and we'll move to week 4. So we won't be introducing Python in week 4. We will just do natural something on natural language processing and conclude week 4. So it's nice having a class with you, and I hope you learned a lot, or you learned new skills that you could explore. Okay, I'll encourage you to go to Kaggle, see how it works, and to start a new project in Kaggle, you just need to use this plus button, the blue one. Click it, and you see a new notebook, and then you'll be able to start your own project, for instance, like this. And you have to name your project whatever you want. Say first FIRST project. So this is how your first project loads, and then you can click out of the box. Okay, and this is how it loads. It loads this sample data. You can always remove it by using this button, but for now it's showing something like this. So you can always also highlight and delete. Yeah, and yeah, you can convert this one to a markdown if you want. Like if it's already a cell, the code, you can come and say, okay, I want it to be a markdown. Okay, and then you can do your comment here to show what you want to do, like what I did earlier into, for instance, I put hash space, I could say variables, and press Control Enter. Then you see something like that, and you can write your code here, which we did earlier, like print John, and press run. So you can press either this run here or here, and you could delete. You could move your cell up above this one, later on or down, and you could stop your session here. You could factory reset to something like, for instance, okay, and yeah. So now this is the Kaggle environment. You can go through it, play with it, and see what you could do with it. Thanks once more for having you guys on this class. Sorry. Bye.